Hello everyone, welcome to Ferdin Speaks. This is my lecture series. Today we are going to see about blockchain technology. I would like to thank all my subscribers so far. Till today I have got around 60 subscribers. Thank you so much. And I would like to ask all of you to share this video among young graduates or those students who are currently pursuing their bachelor's or master's in computer science or information technology or any circuit branches. So this video, I hope it will be useful for them to know about the latest technologies. So last week we had a lecture on the introduction to blockchain. This is the continuation part of the previous lecture. So today we are going to see the tools and technologies to be used for blockchain technology. So with today's lecture you will get familiar about the most commonly used terminologies for blockchain technology. So most of the technologies or the terminologies used in blockchain technology is like quite the name will be quite unfamiliar, but if you really understand what it is, you can get to know about it easily from the basics of distributed systems or computer network security or database systems. So all these terminologies are derived from either of these three disciplines. So it's not going to be difficult. You just listen carefully with all the terminologies and you will get to know more about it. So as a part of this lecture series, I'm willing to share all the slides. I have posted all my lectures in Slideshare as PowerPoint, and the link of those PowerPoint lectures are provided within the description of this video. So please go through those slides and get more information about my courses. So thank you for your support. So let's go on to the second lecture on blockchain technology. Welcome. So today we are going to see about the blockchain terminologies for the part of week 2. And last week we saw about an introduction to blockchain. And today we are going to see about blockchain terminologies and various types of blockchain. There are so many types of blockchain, so we are going to see them as well. So this is like a recap of the previous lecture. This is how blockchain works. Um, So here we have a computer which is performing a transaction, that is, it is initiating the transaction. So that transaction is sent to various nodes across the network. So the copy of that particular transaction is sent to all the nodes, that is all the computers connected to that particular network. So this network will perform a consensus algorithm. A consensus algorithm will verify whether the transaction is valid or not. So once the transaction is valid, the transaction will be accepted in the database. When it will be accepted? When all the nodes in the network say that the given transaction is valid, then the transaction will be allowed to get stored in the database. Then that particular transaction is connected in a chain of transaction, and these chain of transactions are stored in blocks. So these blocks will have the hash value of the previous block, and inside the blocks each transaction will have the hash value of the previous transaction stored as a chain. So these transactions in a chain are stored in the block, and the blocks in chains are connected to each other. That is why we call it as blockchain. So this is the basic working principle of blockchain. This is what we saw in the last week's lecture. So how a block looks like, uh, I told you, like, the transaction will normally have a list of transactions stored in the blocks. So here I can show you, like, this block over here. So here we have like block number 98, block number 99, 100 and 101. What is inside the block 101? It will have a version info, that is the information regarding the version of that particular block, and then it will have a nonce value. Nonce is normally used for security purposes. So that is like one signal value which is normally used for the encryption and decryption of data, and then the hash value of the previous block's transactions. So that is the hash value of this block 100 will be stored in this previous block, and then the timestamp. What is the latest timestamp of data stored in that particular blockchain? So these all will be stored in the timestamp. And then we have a Merkle tree. Merkle tree is a kind of a data structure of storing transactions in a blockchain. So it will have some number of transaction ID list. So those will be stored in a form of tree. It's nothing to confuse with what is a Merkle. Merkle is just like a tree. Like we have seen in data structures that we have a binary tree or a binary search tree, or so many different kinds of trees we have. So Merkle tree is also a kind of tree. So we will see about that Merkle tree in the coming slides. So before that, we see how these blocks are connected. So here this picture shows how three blocks are connected. Firstly, we have this block number 1. So the block number 1 will have these transactions for the block 1, and these transactions are stored within a tree. This tree will have the Merkle root as the root node, and all the transaction or their child nodes, and then it will have the hash of the previous block 1. So this is block 1. So the hash of the block 0 will be stored over here. Next, when the block size is full, it will move to the next block. So this block will have the hash of previous block. The previous block is block 1. So the block 1's hash value is stored in this part, and then we have the Merkle root, which will keep storing the transactions within the block number 2. So we finish with the block 1, and then any transaction which is happening, which will be stored within the block 2 with this particular Merkle root, and then it finishes this block 2 and keeps going to the block 3. So when it goes to the block 3, the hash of previous block header, that is the hash of block number 2, will be stored in the hash of previous block header in block 3. Then as usual, the Merkle root keeps storing the block transactions. So this is how the blocks are getting created in a blockchain. So how many transactions can happen inside a block? We normally have a fixed size for a block in a blockchain. All the block in a blockchain are of the same size. So like it cannot have like one block like 1 gigabyte or another block like 2 terabyte. It's not like that. So you have to fix a particular size of for the blocks, and each block will have the same size, and once the block size is filled, it will move to the next block. So here we have the block over here, the first block, previous hash, and then the nonce and the Merkle root and the timestamp. So the Merkle root will normally have the hash value of the transactions happening. So these Merkle roots will have a tree-like structure of all the hash values of transactions. So if the transaction is altered, then it has to alter the tree as well. So imagine there is only one computer, you can make any change within any list, but when it comes to a consensus and it has to get an approval or a verification from the nodes all over the network, it is practically impossible to hack or to alter any data in this blockchain. So it is not that easy to hack these systems. So that way we say that blockchain is much robust and it is very much safe and secure. So here this picture shows the structure of a Merkle tree. So we saw about the block, how the block get created and how the hash value of the previous blocks get stored and how the transactions are getting connected. But how the Merkle tree is formed? Initially we have transaction A, transaction B, C and D. So these transactions will form a hash value for each transaction. So these hash values are combined together. The beauty of hash value is like it involves some message digest algorithms. So there are so many hashing algorithms. What it does is it will take two values of the same or identical size and combine together to form another hash value which is of the same size. So even if you alter one bit of that particular hash, you cannot be able to retrieve the actual transaction. So it is not that easy to alter one particular bit or two bits or whatever it is in a particular hash value of a transaction. So this is how the hash value A and B gets combined to form the hash value AB, and then we have the combination of hash value C and D to form the hash of CD. So then AB and CD will form a combined hash. So like this it will form a tree. This tree structure is called Merkle tree, and the root of this Merkle tree is the Merkle root which is present in any block in a blockchain. So this is how a block chain gets created. Now hashing. Hashing, it will have an input data, and that is here we have the transaction details and its timestamp details and the hashing algorithm. So these timestamp and the details of the transactions are fed into a hashing algorithm, and this hashing algorithm will produce an output hash. This output hash is used for making this kind of secure hash values which is not understandable by any hacker. So this is how hash is formed. The detailed information on hashing will be explained in the lectures from week number 5 to 7. And then these algorithms are harder to hack, and it is not easy to hack within the time span of the algorithm's performance. And then we have consensus. Where do we use the consensus? When we send a transaction across a network having n number of nodes, for verification there are a lot of consensus algorithms which do a consensus mechanism which will verify whether this transaction has to be approved or not. For that there are so many types of consensus algorithms, but the most peculiar ones or the most famous ones are like proof of work or proof of stake, and there are so many other methods as well. The reason why this proof of work and proof of stake are more popular is it is used in the Bitcoin blockchain, and it was actually proposed in the white paper of Satoshi Nakamoto. So in the previous lecture I gave the link for the white paper of Satoshi Nakamoto on blockchain. It is like a white paper which is having a lot of citation. It is quite wonderful. Like like when we publish any paper, it is like we go for some famous journals and we wait for some number of months to get published, and we wait for the people to cite our work. So it's quite kind of fishy. So but this guy has published a white paper which will be which is gaining more popularity. So people who are writing any article or any research methodology on blockchain, they cannot ignore this white paper. So kindly read this white paper, so you will get to know the real or the original idea of blockchain from the creator of blockchain itself. It is like the book written by John Strustrop for C++ or Dennis Ritchie's book on C. So you can just have a look on those that white paper by Satoshi Nakamoto. So proof of work and proof of stake, like in our network, some people will be mining bitcoins, or some will be having a lot of bitcoins. So proof of work is for those who mine bitcoins, and proof of stake is for those who own a lot of bitcoins. When we see about proof of work, these guys don't actually go and buy bitcoins. It was actually easy during the years 2008, 9, 10 when people normally get bitcoins easily by mining. So those days the value of bitcoin was not much, but today it is of a huge fortune. One bitcoin will cost like a few thousand US dollars. So it is a big deal now for them. So they are like, they have done a lot of verifications of transactions in the Bitcoin blockchain. So they have gained Bitcoin's share as a part of their mining income. So those who have done a lot of proof of work, that is a lot of Bitcoin mining, have more chance for approving any transaction than any others. That is what we call it as proof of work. We have like 10 nodes in the network. Node A has a lot of work done on the verification of transactions than any other nodes in the network. Then it is like a veto power for that particular node. It can override any other nodes in the network because it has done a lot of work on mining and verifying the transactions in the blockchain. And then we have this proof of stake. These guys don't do any mining. So what they do, they are like some big magnets, like they have a lot of money and they buy a lot of bitcoins and they increase their stake. So they are like a shareholders of investment, like they invest a lot of money on these blockchain networks. So they have a lot of cryptocurrencies, and their wealth in that particular blockchain is more. So those who are having more wealth in that particular blockchain will have a kind of possibility to verify any transaction more than any other nodes. They can give more approvals than the other nodes. So this is how the proof of stake works. We will see in detail after the week 7 on these consensus mechanism. There are a lot of consensus mechanisms available. Proof of work and proof of stake are just two types, that's all. So we will see more in detail in the later lectures. So if it is proof of work, we can see like there are a number of nodes. Here we see like there are a lot of nodes which are connected all over the world. So this is how the miners get to work from various parts of the world, and they keep mining all the transactions and verify the transactions. So more the transactions verified, then they will get more number of cryptocurrencies. And then this is like a miner. So like here everybody, Paul is creating a transaction and all the others are being a miner. and they will do some verification. Here Bob, Johan, Alice and John will have like a positive impact on the network, while pig is a malicious node, and that will be like saying it is not a right one, and then if pig tries to change anything, the other remaining nodes will say this transaction is not valid. So even if pig is not approving, it gets the approval from Bob, Johan, John and Alice, so Paul's transaction gets validated. In case if pig alone gives a verification and the remaining people say it is not valid, then that transaction is not accepted as a part of that particular blockchain. So this is how it works. All of them say okay, then the transaction will get accepted in the database. Proof of stake. As I mentioned, it's like a miner of a new block is chosen in deterministic way depending on the assets or holdings, also known as the stake. How much he has mined and how much value of coins or cryptocurrencies he is owning. All these counts to make him to verify a block. Miners do not receive a block reward but collect transaction fees as a reward. So for each transaction, these miners will be provided with a particular amount of income. Proof of stake system can be very much cost of energy and efficient than proof of work system, but are not much proven rightly. So now we have seen all the terminologies in blockchain technology. Now we are going to see about various types of blockchains which are available. So when you see the slides in Slideshare, there are some videos which I have not included as a part of this video series, because those videos are taken from various sources of YouTube. Due to community standard violations, I have not included those videos in this lecture. So you can have the link of those YouTube videos from my slides which are posted in Slideshare. Next we will be seeing about various types of blockchain. There are four types of blockchain networks. Firstly, we see about the networks of blockchain. We are not directly going into types of blockchain. Firstly, we will see about the blockchain's networks. We have private blockchains, that is the blockchain which is available only for a particular group. Public blockchain, that is like a Bitcoin blockchain that anybody can enter and anybody can use. And then semi-private blockchain, it will be available in public but using some kind of permit levels. The usage will be restricted. And then you have consortium blockchain. Consortium blockchain is like a group of blockchains and it has some special privileges. So these are all about the types of blockchain networks. So the various features of blockchains, I told you about the types of blockchain. We have public blockchain, consortium and federated and public, or sorry, the private blockchain, and then we have blockchain as a service. Public blockchain, we have everybody can join and it is transparent, no need to trust others, security based on consensus protocols and hash functions. Examples are Bitcoin, Ethereum, and generally they are crypto based. And in consortium or federated blockchain or a private blockchain, they are normally permissioned. They normally they are like within a particular network, as only a small set of people are given privilege to use. It's just like an intranet. It's not actually an intranet, it is available in internet, but the access to that particular blockchain is available only for a certain amount of people. And blockchain as a service, we can call it as BaaS, like just like a software as a service, infrastructure as a service, or like platform as a service. so many things are available, just like an advent of cloud computing. Various softwares are given in the cloud. That's what we call it as software as a service. Here we have something like the softwares which are used to create blockchains. They are given into the cloud in this blockchain as a service, and for a particular amount of fee we will be allowed to use these blockchain softwares in the cloud, and we can create our own blockchain using this blockchain as a service. So this is about the various features of blockchain. And then we have this public blockchain. Public blockchain, as I mentioned, it can be used by anyone. So the buyer is sending some money to the seller. So what it happens, firstly he will initiate a transaction. It will be, the transaction will do a crypto hashing, and it will be sent into the distributed databases. What is distributed databases? It is this database which is available with each and every node in the network. So each and every node will have a database, and then it will have like a trustless peering. Like each node will send a value which says whether the transaction is valid or not. If the transaction is valid signal obtained from almost all the nodes of the network, then the transaction is successful and the seller will receive the money from the buyer. So this is how a transaction is done within a public blockchain. Next we have a private or consortium based blockchain. So this is like a regulated kind of blockchain. So this regulated blockchain is like you will have a middleman. So normally this is not actually a blockchain. It's technically a blockchain, but it is not actually a blockchain. So it is a private blockchain which has banks as a regulatory factor, which will have a track on all the transactions made, and it will have a say on each and every transaction which is done in the blockchain. So it does the same thing as the public blockchain, but it will have someone in the middle, and this blockchain will be available for only a particular set of users. So this is like a consortium blockchain. It is like how it will keep tracking the transactions from various subnets in the network. And then we have sidechain. Sidechain is like a kind of technical term. We have main chain and side chain. So normally we have a Bitcoin as a cryptocurrency. Bitcoin is not actually a blockchain. Like it's not only blockchain. It's like it's only a cryptocurrency, and the channel through which bitcoins are transferred is only through blockchain. But the people normally have a misconception that Bitcoin is blockchain. It is not blockchain. Bitcoin is a cryptocurrency. It is a virtual currency made for transactions in blockchain. That's all. Like you can use bitcoins, or you can use Ethereum coin, or you can use Stellar coins, or whatever. You can name your own coin. For example, Donald Trump can create his own coin, or anyone like the person X can create X coin, or Y can create Y coin. You can create your own, you can name it like your name coin itself. So you have a main blockchain, and you have a separate network which is linked to the main network. So something, it's like main chain, it's like a cryptocurrency like US dollar is moving in, and side chains are like the local currencies of various countries, like countries like the Scandinavian countries and several other European countries, they use euro, and the Arab countries use reals, and India use rupee. So these separate currencies are in separate side chains, and US dollars are in the main chain. Like all the transactions are mostly happening with the US dollars, so they are like the main chain, and the normal currencies are like the side chain. So in blockchain, it is like main coins or the main cryptocurrencies are done in the main network of blockchain, and side chains are like you have your own kind of sub network where you will store a particular kind of crypto coin which has the value of the main coin, but you keep it in a different name and you keep it in a different network, and that coin can be used only in that particular sidechain. That is the beauty of sidechain. You can have a particular privacy in that sidechain. So this is how the sidechains are made to work. You have the main blockchain, and this main blockchain will be connected to a list of sidechain. So this sidechain will have a kind of separate smaller blockchains, and these smaller blockchains will keep sending and receiving the transaction values, so based on the cryptocurrencies given in. So this is the description on the sidechain. It is a separate blockchain attached to another main blockchain offered to us the main chain. That is why we call the main blockchain network as the main chain, and these smaller networks as a side chain. They are attached to each other using one or two-way peg. Like you can make it like a one-way transfer or a two-way transfer of transactions between the main chain and the side chains, or you can like make it like one single, or it's up to you. So this means that the assets on the main chain and the side chain can be traded with a predetermined rate. You can fix the rate for that assets. Next, the types of blockchain networks. We have centralized, decentralized, and distributed. In the centralized, you can see one particular node in the center will control all the nodes in the network. But if that server goes down, of course nothing can be done with that particular network. That network is dead. But in the case of decentralized network, you have so many different servers. Like there is not only one server, there are multiple servers connected to multiple networks. So in that case, if one server goes down, all the other servers will be running, so the nodes will be using the then it is like it will use the nodes, the servers from the various other servers. So if one particular server is not working, then that particular network alone will not work, but the remaining network will be working and it will be up forever. And then we have the distributed blockchain network. This is the predominant type of network we use for blockchain networks. So distributed, it is like there is no server, no client, all are servers and all are clients. It's like a true democracy, like all are the kings of that particular country. So it's like you have any node which doesn't function well, then that gets inactive, but all the other nodes, their functionality will keep intact and it will be up for like a normal functionality. Then the type of blockchain based on value. There are token based blockchain and tokenless blockchain. So token based blockchain means it will have a cryptocurrency value. Like we have like a non-intrinsic token, that is token based blockchain, and intrinsic token. So if you see about this non-intrinsic token, we can have like a Bitcoin blockchain or Ethereum Stellar blockchain. It is having like one particular coin, altcoin or whatever it is. If you are given with a token which is built using the smart contract, then it is called as non-intrinsic token. And intrinsic token means it will have like it is not actually a physical coin, like you cannot count as a coin. It is some value which has a protocol of consensus algorithm, and it falls under the distributed ledger. So then the smart contracts, we will see in detail about these smart contracts in lectures later, in the later weeks. So here we don't have the work of middlemen. Who are the middlemen over here? A legal advisor or a government agent or a financial advisors. Normally these guys are making a lot of money in all the transactions. That's why most of the governments are not really willing to implement blockchain in their financial transactions, because it is more transparent and it will give out the details of who is making the fraud and who is not making the fraud. So that's the kind of criticality over here. But when you have these smart contracts, these guys, the government agents or the legal advisors and financial advisors, will definitely lose their jobs actually. So here we have the smart contracts, we have the money and the data transferred. Like the smart contract is like a computer code. It's like a executable program which will execute only when all the conditions in that particular contract is met. So it's just like you are getting a contract done for renting your house between you and your landlord, or you are getting an office space from some business people, like you will have some contract. It's as like that way. So that's all about the basic of smart contracts you need to know about. And in the next slide, we have the advantages of blockchain. So it is like a decentralized system. So that is, all the nodes are server and all the nodes are clients. So even if any of the transaction fails or any of the node fails, the remaining nodes will take care of the transactions, and it is transparent and it is more trustworthy, and it is highly immutable, and the availability and security are more for this blockchain than the traditional storage of network. A simplification of current organizational operations, it will definitely remove the practical difficulties of various organizational operations. It will do a faster dealing and it will save the cost. Like if you do some transactions with Visa or PayPal or whatever it is, they will definitely get a particular amount of your transaction as a fee. So blockchain, not only Bitcoin, like any blockchain, their transaction fee is much lesser than those of the transactions done using the blockchain. So when you compare all these advantages of blockchain with the classical transaction based systems, blockchain will always have an upper hand. It is more secure. So that's all about the advantages. When we think about the advantages, we also have various limitations. There are limitations on the scalability, adaptability, privacy, regulation, and relative immature technology. It is immature technology because it gained its popularity only during the recent years. So it started gaining its popularity only from 2008 to 2015, and now it is slowly growing on. So this is like an emerging technology, a new technology. So it is like an, you cannot actually say it as an immature technology, but because of the experience people have in this technology, it is termed as a relatively immature technology. And there are no government regulation, and the privacy is not obtained to the adequate levels, and it will have an adaptability and scalability issues. Like scalability in the sense how many people can actually access the database. That is actually a big research issue in the case of blockchain. So here in this slide, it displays about the transaction speed of various financial network nodes. So Bitcoin takes like around um, 10 transactions per second, while Visa transactions are like 24,000 transactions per second. So in case if 24,000 users can use Visa transactions in 1 second, and the same 24,000 users use Bitcoin, there is a scalability issue in the case of Bitcoin blockchain. Then we have this Ethereum, it does it quite faster, like it is 30 per second, and Dash coins have 60 per second, Litecoins have like 70 per second, like that so many others. The fastest cryptocurrency so far is like the Ripple. Ripple is the most recent one, and it is doing quite well. Like they are really doing a lot of development in this particular cryptocurrency. So next we have like the real world situation. We can actually create a blockchain for Uber, like car booking system. Like it will be like a decentralized, so the drivers or the passengers don't need to rely on the centralized system which will allocate the cars or the drivers for them to travel, or the drivers getting orders from their customers. So it is like a decentralized system, and Uber can really do well. So systems like Uber can actually do this kind of implementations using blockchain. So there are some additional resources. So these YouTube videos are actually helpful for you to know more about various implementations. There are some Bitcoin ATMs in Bangalore in India. Bangalore is like a Silicon Valley of India, and Bitcoin payment restaurant is also available there. So it's actually like an eye opener for any retailers wanting to enter the blockchain stream. So then we have like the cryptocurrency in Western Africa. So that video is also given in this slide. So that's all about this week. And next week we will be seeing about fintech, that is financial technology, and various cryptocurrencies. So we will know about